Welcome viewers. In today's video, we'll be knowing and understanding the laws of indices, knowing that they are all true for all values, and also we'll know how and when to apply them. Please don't go anywhere. If you are new in this channel, Insight Maths, remember to subscribe and also comment. Okay, the laws of indices are as follow. Yeah, these are all the laws of indices. Now, among them, we have three fundamental laws of indices. Yes, we have three fundamental laws of indices, which are the addition law, subtraction law, and multiplication law. They are the three fundamental laws of indices. Okay, we'll be going through examples relating to all these laws to get better understanding of. For the first law, where we have 10 raised to the power of 5 multiplied by 10 raised to the power of 2. In this, we found out that the two questions has the same base but different power. So we bring one of the base and then we sum their powers together to give 10 raised to the power of 7. Also for the subtraction law, where we have 22n raised to the power of 7 divided by 2n raised to the power of 3. Now in this, we found out that the coefficient of n for the two are different, meaning the base are different. So we divide them as usual. 22 divided by 2, which will give us 11. Okay, now we find out that the both has the same base of n. So we say 11 multiplied by n raised to the power of 7 minus 3 as the second law of indices, whereby the division when go to the power we turn into subtraction. 7 minus 3 to give us 11n raised to the power of 4. Yes, this is for the second law. Now for the multiplication law, as you can see, we have a question relating to that, where we have this open bracket x raised to the power of 2 close bracket 3. Now when you see a number raised to the power of 2 is known as square, 3 is known as cube. Okay, now is equal to, just like the law implies, we say x raised to the power of 2 times 3 to give us x raised to the power of 6. Even if the x should be 4, it will still give us 4 raised to the power of 6. If you should solve this thing in a normal pattern, which will be longer, give you longer time, you will spend much time, it will still result in the same answer. Now for the second one, we have x raised to the power of minus is equal to 1 over x raised to the power of a. Now this is very easy. For example, I have a question related to that. 5 raised to the power of minus 2 is equal to, that minus will stand as a numerating 1 divided by 5 raised to the power of 2 to give 1 over 5 times 5 give us 25. Yes, in any question again you see relating to that, that's the way to solve it. Now for this one, we have x raised to the power of 0 is equal to 1. X cannot be equal to 0, so it must be at least 1. That is to say, anything raised to the power of 0 is 1. Either 15 raised to the power of 0, 1, 20 raised to the power of 0, 1, 566 raised to the power of 0 is also 1. Okay. Now for this, we have x raised to the power of a divided by b is another law of indices, where it gives b root x close bracket square of a square. Okay, we have a question related to that. 9 raised to the power of 2 over 3 is equal to 3 root what? Will you guess? Now if you look at a question like this, where we have 9 raised to the power of a fraction, to solve it, the denominator will form a root, then the numerator will square them up. Just like you see, the denominator, which is 3, has formed the 3 root. Now the 2 there will square them up. Now 3 root 9 will close them and square them up. Yes, if the numerator should be 4, we square them with 4. If it should be 5, we square them just like that. Now Bodmas will say bracket first. So we must solve what is in the bracket before solving outside. That is equal to root 3 root 9 gives 3. Then close brackets 2, which will give us 9 as the answer. Okay, we have another question where we have 4 raised to the power of 1 over 6 times 4 raised to the power of 1 over 3. Now this is a mixture of the first law of indices and also this law we are just in now. So we'll find out that they have the same basis. So we'll bring back one of the base, then we'll sum up their power. So 1 over 6 plus 1 over 3. Fraction, when you solve this, it will give us 1 over 2. So when you have reduced it to lowest term, so 4 raised to the power of 1 over 2 is our answer. But this shouldn't be the end of the answer, because we can still solve further. Then using this law, we say we root them. The denominator, which is 2, will form a root to be root 4. Then it can be squared with 1. Anything squared with 1 will still give it that same answer. So there's no need to be equal to 2. Yes. If you're new in this channel, please don't forget to subscribe, like, and also comment. Thanks. I love you. Bye.